So now we're going to begin 6.8, part B, which concerns addition and subtraction of complex numbers. And this is actually pretty straightforward. It's basically the same as adding two linear polynomials if you treat I as a variable. So let's say we had two complex numbers. So we have A plus BI and C plus DI, where A, B, C, D are real numbers. Okay, so if we want to add two complex numbers, basically we're combining like terms. So just combine like terms. So it works exactly like you were adding two linear polynomials. If you were to treat I like a variable, it's not a variable. Remember, it's that special number that we called one of the square roots of -1. But addition works exactly the same way. So here we would add the two real numbers. So I'm going to combine, I'm going to combine the two real parts together. So if I add the A and the C, that becomes A plus C. That will be the new real part. And then I'm going to add the two imaginary parts, the B and the D together. Okay, that becomes B plus D times I. This is the new imaginary part. Again, this is just a fancy way of saying combine like terms, like you normally would. Subtraction is almost the same. So for subtraction, if we are, for subtraction, if I were doing A minus B, or A plus BI minus C plus DI, it's basically the same idea. One option would be to distribute that negative in. And in fact, that's how I'll do it in examples. Just try to move this down a little bit. And that's how I'll do it in examples. But again, it's just subtraction. So what I'm going to do, is I'm going to combine, I'm going to do A minus C. That's going to be the new real part. And then I'm going to do B minus D. That's going to be the new imaginary part. So that's really all you need to know about adding and subtracting. So I'll do one example here before we get to the handout examples. So here's just one. Here's an example. So let's say I had the complex number, say 2 plus 7i, and I was subtracting the complex number 1 plus 5i. So because it's subtraction, I'm just going to subtract the real parts separately from the imaginary parts. So this is going to be 2 minus 1 plus, plus, and then I'm going to do 7 minus 5. That's going to be the new imaginary part. So this is just going to be 1 plus 2i. And that's really all there is to it. I will do the examples on the handout now, just so we have additional couple of examples, but not much to it, right? So let's look at the handout examples. And I only have a couple of them because this I think, it just relies on previous knowledge of combining like terms. So on the handout, I have the following two examples. So this is numbers 5 and 6. The first one is to add or subtract, so that's the directions. So we have 5, so we're add or subtract. So we have 5 minus 7i plus 2 plus 9i. So here, just as if I was a variable, I'm basically combining those two terms together. They're like terms. And I'm also going to combine the 5 and the 2 together. So this becomes 5 plus 7, sorry, 5 plus 2, which is 7. Maybe I'll just write out the work here. So this becomes 5 plus 2, that's the new real part, plus the imaginary part will be negative 7 plus 9 times I, right? So this is the imaginary part here, and this is the real part. Okay, just simplify that. That becomes 7 plus 2i. If this coefficient of I had been a negative, I would have just changed this to a subtraction. That'd be the only difference. Let's look at number 6 here. Number 6 is the following problem. 3 plus 2i minus 6 minus 4i. So we're subtracting these two complex numbers. And just like we did before in that first example here, the one in red, I'm going to subtract the real parts. So I'll have 3 minus 6 as my new real part. Subtract those two. Okay, plus. Then I'm going to subtract the 2 and the negative 4. So be careful here. The imaginary parts are positive 2 and negative 4, and I'm subtracting them. So we're going to end up with that double negative. We're going to have 2 minus negative 4 as our new imaginary part. 3 minus 6 is negative 3. 2 minus negative 4, that becomes an addition. So I'm going to have a positive 6i. And notice how I'm writing all of my answers. All answers, all final answers for complex numbers we always want to write in the form something plus or minus, could be a minus, something times I. So we call that A plus BI form. It could be a subtraction in between two, that's fine if it ends up being a negative imaginary part. So all final answers for when we're dealing with complex numbers, we want to write in that form. So I hope those examples were clear. You could always, again, rewind, retry, and I'll leave it at that. Try out the homework questions, and of course, come with questions in class. So now we're going to start talking about multiplication. That was part B. 6.5 part C is all about multiplication. So for the multiplication of two complex numbers, there's two main things we have to keep in mind. So the important ideas are, one, we're going to use the fact that square root of A times B is the square root of A times the square root of B, but only when at most one of A and B are negative. If they're both negative, you can't use this rule. So what I'm going to be doing pretty typically is, if you're worried about making a mistake, always, again, if you're worried about making that mistake, so always simplify the square roots of negatives first. Before multiplying. The expressions. Okay. The second thing we're going to use is the fact that I squared is equal to -1. All right, that's what we talked about in the intro. So if I squared is -1, there should be no I squareds in your final answer at all. Okay, no powers, in fact, no powers of I larger than 1 should be in your final answer. So no powers of I except I itself should be in your final answer. And the reason is because you could always reduce it, right? So we're going to talk more about higher powers of I in the next video. I'm trying to make these a little bit shorter than like an hour video. So I'll do parts D and E in the next section, in the next video. But we want to make sure that there's no powers of I except for I to the first power. Because if there's an I squared, let's say you were left with 20I plus 10I squared. That could very well be the correct answer to the question. But this I squared, because it has a power that's larger than 1, we could reduce it. We can replace that. I squared is just -1. So I would keep simplifying at this step. I would write this as 20I plus 10 times -1, which would be 20I minus 10. And then I would rearrange it to put it in, again, I'm going to scroll up for a sec. Right here, we want to put it in A plus BI form, which means we want the real number part first. It's just standard to write it that way. So the real part of this complex number is -10. And the imaginary part is 20. So we're going to have 20I. So if what you started with is 20I plus 10I squared, okay, you'd want to reduce it to this last expression here.